Okay, we've all been there. You're on call, maybe it's the middle of the night, and that dreaded alert goes off. A critical service is slowing to a crawl. And the culprit? A Docker container just sitting there with its CPU absolutely pegged at 100%. It's a total panic situation, right? Well, today we're going to turn that panic into a solid, step-by-step plan.
I want you to think of this whole scenario not just as a technical glitch, but as a crime scene. Seriously, there's a rogue process in there that's stealing all the system's resources, and you're the detective on the case. Your job is to find that culprit, figure out its motive, and get things back to normal. So let's start the investigation.
Every good detective needs a plan of attack. Here's ours. First, we'll survey the scene from the outside, the host machine. Then we'll zero in on our prime suspect, the container. After that, we go inside to find the specific troublemaker. Then we uncover the motive by digging through logs and configs. And finally, we'll find that root cause. Let's do this. First things first, we have to understand the whole environment. Before we start pointing fingers at any one container, we've got to check the health of the host machine itself. Is this a problem with just one container, or is the entire system under stress? These are your first tools out of the bag. Commands like top, htop, or a good old ps command give you that bird's eye view of everything running on the host. We're on the lookout for anything, Docker-related or not, that's just eating up way too much CPU. And this right here is a critical clue. If your host machine's CPU is just screaming for help at over 90%, then the problem is way bigger than a single container. At that point, every process is fighting for scraps of power. You've got a host-level problem to deal with first. All right, let's say the host looks perfectly healthy. Now our investigation gets more focused. It's time to figure out which specific container is making all this noise. We need to identify our primary suspect. The absolute best tool for this job is Docker stats. Just think of this command as a live security feed pointed at every single one of your containers. It shows you in real time exactly what resources each one is using. This is our virtual stakeout. And when you look at the output, well, the culprit usually stands out like a sore thumb. Look at this. Our web app is practically on fire at almost 100% CPU, while the database and cache are just chillin'. We've found our guy. But hey, don't just stare at the percentage. There are other clues here. Is the CPU time value for one container ticking up way faster than the others? Or maybe you see activity in a container that should be completely idle. These are those little details that really confirm your suspicions. Okay, we've identified the container. We've got our suspect cornered. Now it's time to breach the perimeter and get a closer look. We need to find the exact process inside that container that's gone rogue. It's interrogation time. And the command that gets us inside is docker exec. This drops us right into an interactive shell inside our target container. We're now in the room with the misbehaving process, and we can start asking it some tough questions. Once you're in, you've got two main tools. Think of Top as a live video feed, constantly updating and showing you who's using the most CPU right now. On the other hand, PS is like taking a quick snapshot, a photo of everything that's running at that exact moment. Both are super useful for finding that one process ID that's causing all our grief. So what are we looking for? Well, these are the usual suspects, the motives, if you will. It's usually not something malicious, it's just a bug. An infinite loop in the code, a thread that's just stuck in some heavy calculation, or even a garbage collector that's just working way too hard. So finding the process is one thing, but understanding why it's acting up is the real key to solving this case for good. And to do that, we need to gather more evidence. It's time to dust for prints, check the logs, and review the container's configuration. The Docker logs command is basically your window into what the application has been up to. A lot of the time, the app itself will be screaming about what's wrong. It might be yelling about the same error over and over again, and all that yelling is what's eating your CPU. You want to look for patterns. Are you seeing an endless loop of exceptions? Or maybe a retry storm, where the app is frantically trying to connect to a service that's down. These kinds of log entries are basically a written confession. And don't forget this, sometimes the problem isn't in your application code at all. It's in how the container was built. A misconfigured Dockerfile might be running the app in a slow debug mode, or using a bloated base image, or even starting up some extra processes you didn't know about. The flaw could be in the blueprint itself. We've gathered the clues. We've interviewed the witnesses. We have a suspect and a motive. Now it's time for the final step, deep forensic analysis. We need to find the absolute smoking gun, the exact function, the exact line of code that's causing this whole mess. And this is where we bring in the specialists, language-specific profiling tools. Whether it's PySpy for Python, pprof for Go, or something like jstack for Java, these tools are like a powerful magnifying glass for your code. They can tell you exactly which functions are being called the most and where all those precious CPU cycles are going. And this brings us to maybe the most important rule of the entire investigation. Resist the urge to just restart the container. I know it's tempting. A restart might make the problem go away for a little while, but you've just destroyed the crime scene. You've let the culprit get away. Always, always diagnose first. So let's recap the whole thing with this handy detective's checklist. You start broad at the host level, you narrow down to the container, you go inside to find the process, you check logs, you check configs, you use profilers, and only then, at the very end, do you restart. Following these steps turns a stressful firefight into a calm, methodical investigation. So now you have the playbook. The next time that CPU alert fires, you'll be ready. You can put on your detective hat and crack the case. Which leaves me with one final question for you. What's the most surprising or weird or unexpected root cause for high CPU that you've ever found in your own investigations? Because trust me, those stories are often the best lessons. Thanks for joining me.